Okay. So I guess we can get started. See if I have control. Yes. No, because this is still duplicated for some reasons. All the other ones are separated. This one is duplicated. Doesn't matter. It's fine. Okay. Good morning, everyone. For the people present here this morning at the Beacon in Antwerp, and to all the people online. Today we're having our usual webinar plus our annual meeting of OpenCloudification. My name is Luca Gattobiggio. As Innovation Manager at LSEC, and as usual, on a monthly basis, we're bringing these webinars, trying to bring some knowledge and some expertise in the cloud scenario, especially on the open source and open cloud solutions available. Today's webinar is going to be about backup and data storage. But first, a little introduction about LSEC, what we do, and what are our projects. A very short introduction. So our main website, lsec.eu, we define ourselves as the digital cybersecurity catalysts. We try to bring innovation in cybersecurity, and we try to help other companies, especially small and medium enterprises, improving their cybersecurity. We do that with a set of projects, one of which is OpenCloudification. OpenCloudification, as I said, it's an open source focused project to help companies getting introduced in the cloud, or if they're already in the cloud, trying to innovate and keep the state-of-the-art research and bring it to the industry. The main website of OpenCloudification is opencloudification.com. There you can see all our activities. We record all the webinars, so they're also available on demand. And we have a set of tools and guides that you can check on our website. OpenCloudification is a project brought by 3 partners, one of which is LSEC. The other 2 are IMEC ID Lab from Ghent and the Beacon from Antwerp. What we try to do, as I said, is bring some tangible results. So we would like to have something practical, an actual and practical way of helping companies. And we do that organizing a series of webinars, for example, or workshops. We try to define best practices and guidelines. We try to do the research for you on what are the most useful or more interesting tools available right now. For example, the CNCF, so the Cloud Native Computing Foundation landscape, is a good central point on our research. Here you can see the amount of open source and non-open source tools that are part of the cloud environment. And as you can see, it's quite complicated to navigate this forest. So what we try to do is also give you some guidance on which ones might be interesting tools and solutions based on your needs. But we're also part of several other projects. We're also part of the Digitalis project, in which we can practically help manufacturing companies with their digital transformation. So we're financed by the European Commission, and we can bring expertise, but also academia and industry experts to help you digitalize your infrastructure. But to check all our projects, healthsec.eu is the main website. Now we move to today's presentation, today's webinar, which is now not in the correct format. See if I can recover it. Okay. Okay. Should be visible for everyone. So this morning, we're going to have a webinar about backups and data with a focus in multi-cloud, but of course, the main concept will apply for single cloud or for backups and data storage in general. The agenda is quite simple, although the webinar might be a bit long because there are a lot of topics to talk about. So I tried to concentrate mostly on the best practices and some recommendations that might be interesting for someone who's interested in having backups or storing data more in general in the cloud. And of course, we're going to start with a bit of an introduction on why you need backups, what types of backups are available, and how does it work in the cloud. And then we're going to focus, so the main focus will remain the best practices. And we will bring some examples of the tools that are currently available in the cloud native landscape about focusing mostly on backups, and a little discussion at the end on the future trends and some considerations that we should be consider for the future. So let's get started with trying to understand backups. Of course, backups are something that have always been there in the IT world. In general, there are main causes for the need of having some backups in your infrastructures. And this doesn't only applies to the cloud, but applies in general. But we will see that more or less the reasoning behind are similar. There are some additional subjects or topics that you should include, some additional considerations that you should include, whether you talk about the cloud. But the main problems or issues or challenges that you might face are grouped in these 5 categories. So either you will have a media failure, you will have a human error, some problems with software updates, potential cyber attacks, or the entire infrastructure failure. But we will go into details talking about cloud. So as I just said, backups are essential for data protection and for recovery. So the main reasons behind having it in the cloud is, once again, that you want to prevent losing data. And this could happen for several reasons. Someone might delete it accidentally. Data might be corrupted. So having backups can ensure that you will be able to recover at least part of the data that you potentially could lose. There might be system failures, even in the cloud. The cloud infrastructure can experience some failures as well. So you still need, if you're talking about hardware, a way to recover from those type of failures. And as well, it can have software failures, so bugs, glitches, crashes, and so on. So having regular backups might mitigate the impact of potential issues. The human error is still present. Employees or administrators which they have even more privileges might commit some mistakes, some errors, which might result in data loss. So this is an additional layer of security that you will put in place, avoiding that you might lose data. And since we're talking about cloud, this is more a need than an actual issue, but the system might become too complex to have a general overview, especially if we're talking about multi-clouds. And then having backups will make you feel a bit safer in the sense that not having the full overview of all the data spread around different environments, if you keep backups of all of them, you know that at least you can always recover that part of the data. But as I said, there are several additional challenges and needs for having backups. The cybersecurity threats are something that we constantly hear more and more often. Ransomware attacks are a good example. So if your data gets encrypted, one of the few ways to get it back if you don't want to pay the ransom is have a backup that you can restore. In some specific sectors, you might have compliance requirements. Some regulations will mandate that the data backup are stored for a specific amount of time, for a set amount of time. And you have to ensure, for example, that you have data constantly available and you will ensure the integrity of the data. But you will do it also for your business continuity. So you want your business to always be up and running, and having backup will let you recover from a potential disaster. And it's also a good way to have version control and rollback for potential changes that might disrupt your operations. And it's also useful in terms of data migration and transfers. If you want to transfer your part of your infrastructure, for example, from one cloud to another one, backups might be a solution. So backups are essential in general, but of course are also essential for cloud. There we have a shared responsibility model, especially if we're talking about public cloud providers, which means that you as a customer of the cloud are expected to take into account the backups because are a critical aspect usually and are part of the customer responsibilities. So you have to provide integrity and availability of your data, and the backup is one of the solutions. And since we're talking about a dynamic and elastic environment, it could be a good way to also manage the data across your environments. Plus, as I said, the environment is more complex, which means also multiple access point potentially or global access point. So you have to ensure that the data is recoverable regardless of where it is physically located. And automation and orchestration are some of the tools that can help you with the process of managing and orchestrating your backups on the cloud. Most of the cloud providers already have solutions that can automate your backups. So what types of backups are available? We can define them in three big categories as a general classification. You will have the full backups as basically backing up all the data that is available, including files and metadata from a specific location, from a specific machine. You can have incremental backups. In this case, you will only make the backup of the changes since the last full backup. And then you have differential backups that will consider only the changes that happened from the last incremental. Of course, then you have several resource-specific types of backups. If you think about virtual machines, then you will have snapshots. A server or a container might need the backups only of the image. So we're talking about an image level backup. If you're just considering your files, then you will have a file level backup. If we're talking of specific resources like databases, then you might have just log backups and so on. So there are several classifications and several resource-specific backups. But to make it simple, which one, and to answer the question, which one should I consider as backups for my enterprise or my organization? Well, it really depends on the specific needs that you will have. Like if we talk about the generic classification, the full backups, of course, will consider everything that is included, but it will also take more time and more resources even to get them stored, while the differential or the incremental backups are faster, but then they will only consider the changes since the previous backups. And yeah, log backups, for example, are specifically used for databases. So if you're working with databases, you will probably consider log backups. If you're working with virtual machines, you will consider mostly snapshots and so on. So it really depends. And are there solutions available in the cloud native landscape? Of course. Most of them are included in the cloud native storage section, not all of them. When we're talking about resource specific, like databases, for example, some of the open source or open cloud databases can also allow you to use. They also include some backup features or functionalities. But in general, the cloud native storage groups all the storage tools available, and most of them will include a backup and restoring solution. This is an example of a table that includes some of the sandboxes or incubating or graduated projects that are within the cloud native landscape. And then which one should you pick? Well, again, it really depends on your needs. It might depend of the target application, so the very right of the table. If you're looking for something more performance critical or a specific type of backup or data, like block storage or object storage, if you're looking for high availability and so on. Most of them, if not all of them, have integration with Kubernetes. At this point, some of them are actually Kubernetes native, but somehow they can also used externally. And of course, all of them include the backup and restoring functionalities, either as an internal feature or with third-party integrations. But again, we will talk about cloud native solutions later on during the presentation. Which one are the decision metrics that you will consider? Well, there are several, and again, depending on your use cases. But I think we can identify 4 main metrics. So again, specific use case requirements could be regulations, could be anything that your company might need. We will talk about data criticality, so a way to differentiate between the different types of data that you might have, and then you want to have the backup. But I think the 2 main metrics are the RTO, so the recovery time objective, and the recovery point objective, RPO. RTO is the maximum amount of time that you want to tolerate of not having available your data during a disaster. In other words, is the time that it will take to restore your normal operations. While the RPO, so the point objective, is the maximum amount of data still in time that you're willing to lose during a disaster. So to give an example that explains even better, consider an e-commerce website, and they set their RTO to 1 hour. That means that within 1 hour, they should be able, after a disaster, to recover and to restore normal operations. While the RPO, if it's set to 15 minutes, that means that they should be able to recover the data from a point in time that is no older than 15 minutes before the incident. So when you mix and combine these four main metrics, you will then define what it's called a comprehensive data protection strategy and a business continuity or disaster recovery plan. This will be part of your plan to recover from potential incident. And then the question would be, where should you store the backups? We will also explore a bit on that. Of course, there are three main options here. The on-premises means that you will somehow store all the backups, all the data within your organization servers. Offsite could be when I say a different location, I mean a data center or something external to your company. Could be the same cloud provider in which you have your resources, or another one, which is also a best practice, as we will see, or an hybrid solution in which you have both on premises and offsite. In that case, of course, you will have to consider also a bit of orchestration and coordination to keep both the environments up to date. One example of the cloud native storing solutions is Rook. It's the only graduated project currently in the section of storage for cloud native. We will hear a bit more about how Rook can be used. Merlin is here, and he will later on talk a bit about their experience. So our colleague from IMEC have some experience on Rook, and we will hear how they use it. But if we focus on storing solutions in the cloud, well, then there we have several options that we can go for. A usual object storage is one of the solution. It's scalable and cost effective. Usually it's used for unstructured data, but that might easily include backups. Otherwise, you would go for a cold storage, especially if you know that you won't need to access and read the backups constantly. This is, again, really depending of the requirements that you're looking for. Some cloud providers, well, most of the public cloud providers have backup services that you will pay for, and they will make your backups and store it for you. This will also usually include additional functions like the versioning or an easy way to recover your data. Or you can have specific backup appliances deployed in the cloud, if they're virtual, or some physical appliances that can help you facilitate backup and recovery processes. Which strategies are available for the cloud? Well, there are several. Again, a potential way is have a cloud-to-cloud backup. So you keep the backup store still in the cloud, but on a separate environment than where the data comes from. It could be the same cloud provider, and in this case, usually you change the region, or it could be a completely separate cloud provider. This will help you against potential outages or data loss. The cloud integrated backup solutions, well, they're also a strategy in the sense that they already have a full set of features to help you keep the backup in the first instance and then recover from it if you need it. Cross-region replication, as I said, it's used different regions or different locations, geographically speaking, and you will replicate the data there in a way that you have redundancy. So if you have a potential outage in one of the environments, you can still recover the data from another one. Or another potential strategy is file level backups only. If you only need file level, then you might move them to a potential cloud drive. This is not the best practice or the best recommendation. It might work if you really have a small amount of data that you want just to keep it safe on a cloud environment, but usually it doesn't scale well. So it's mostly for smaller scale types of backups that you still have to do it manually, for example. And of course, there are some differences between the single cloud environments and the multi-cloud environments. The table tries to resume all the text written here. There's a vendor lock-in issue. This is always the case if you're going with specific cloud providers. If you have just that one, then it might be an issue when you would like to transition to another one. While if you have multi-cloud environments, then the issue might be reduced in the sense that you have access to several different services, or you can even go for the specific one in each cloud, but you still probably will look for something that is potentially interchangeable. So you can still move the data from one cloud to another one. It is simpler if you have just one cloud, because probably everything will be stored in the same location or the same environment, while the multi-cloud aspect means that you need more complexity, you need coordination. But you will also have some additional redundancy and resilience to that, because again, separate environments, separate cloud providers. It's an important feature to have. In terms of costs, well, usually you have higher costs for multi-cloud backups, but that's debatable in the sense that, yeah, it is additional data. You have to move from one environment to another one data, and this usually costs money, but not necessarily it has to be higher. So you're just increasing the level of security, you're having more redundancy, more resilience, which might include extra costs. But as we will talk about costs management, you will see that there are some extra consideration to take into account. Plus, having the single cloud environment doesn't mean that you're excluded from the fact that whenever you will have to get the data out from the cloud, you will still have to pay anyway. Compliance and data sovereignty. Yes, it's easier to follow specific regulations if you have multiple cloud available, that maybe some of them might fulfill your requirements, some of them might not. So you are still able to move around them. While if you have just one specific cloud, then you're tied with their policies, basically. But as I said, multi-cloud means more complexity, so you also need specialized experts or expertise to manage and coordinate everything. Okay, let's move to some of the recommendations that we believe it's important to talk about and to consider. I will group them in 4 or 5 main groups or pillars. Sometimes they define them as pillars. We will talk about data prioritization first, so the different levels of your data that you should classify. We will talk about cost management. We will talk about security measures in general and encryption, automation and orchestration, and then finally the comprehensive backup strategy that we already mentioned, which is basically grouping the 4 first pillars and then add some additional recommendations or guidelines. So we start with data prioritization, why you need to do that, and what are the advantages of doing that. So first of all, data prioritization means that you assign priorities to the different types of data that you have. And the idea there is that you will probably have data that is more critical, that contains more critical information that you want to make sure to always have available. And there's data that is not necessarily needed to be strictly available constantly. This will help you with the resource optimization because you can have different level of security and storage for all the different types of values or data that you prioritized. It will help you with the RTO because you can establish targets that are more suitable based on the different level or the different types of data that you have. If you have specific compliance requirements, then you can set up based also on the type of prioritization that you gave to your data, and you will avoid unnecessary storage costs for something that might be not useful or not needed. And of course, it will help you with your business continuity because you will recover quickly and resume the operation, especially for the data that is really, really important. So what are the main 5 steps? Well, the first of all is identify and assess all your data that you have and set up the categories and place all the data that you will need to store and make a backup for in your systems. Files, databases, applications, anything that you consider important will go to higher level of priority. Anything that is less important will go down in the list in the classification. And at that point, on each category, you will apply a value based on the importance of the data that you want to keep, based on the compliance requirements, based on a potential financial impact or anything that could be relevant for you and for your data. And then you will define the storage tiering. So higher level of security, high availability, different location, geographically speaking, and so on, might be assigned to the data that is mostly critical for you. And then you will go down in the level of features based on these levels. Risk assessment, well, this is more generic than just about the data, but you should do a risk assessment on specific potential issues that might be caused on, and then might include your data. So data breaches, loss of data, and so on. You will define the potential impact that it might have to your operations and the likelihood to happen. This is also a good exercise to help you classify your data. And finally, you will add the security measures that we're gonna talk on the security section. So these are the main 5 steps that you should consider while prioritizing your data. In terms of cost management, well, as we said, it is important to evaluate and consider the costs that will incur based on the storage and the backups that you have to keep. First of all, you should understand the different cloud pricing models in the sense that each cloud providers have different pricing models. Some of them vary the prices based on the type of data, based on the data transfer speed. There are several factors to consider. And then again, each cloud provider has different storage options as well. Some of them are more expensive, but they provide additional features, or they have high availability, or the time to recover is lower than a usual storage solution. So you will also evaluate the different options based on what you need, but also based on the different cloud providers, because they might have different solutions for that. an important aspect before storing data and backups is to have data deduplication and compression, because deduplication means avoiding to have a repetition, like in having the same data stored twice or more than twice. And compression, means compression. So this will reduce the total amount of space that you need for storing it, but also will optimize the costs and the data transfer costs. There might be retention policies, so you will have to define based on your requirements or your business needs to also have policies on how long the data should be stored or what type of data and so on. So policies might be useful to be defined. And of course, the life cycle management. So the data that you're storing at a certain point, for example, will be eliminated. So also you have to consider when and for how long based on your needs. But we were talking about costs. So this is a very small example, very simplified, considering a lot of fixed options. What if I need to store a very small amount of data and it's just a volume snapshot, for example? Is it worth it to use the AWS backup service? Is it worth it to have my own backup solutions and then store it in AWS? Is it worth it to use another cloud, but the data will come from AWS, or there are like just cheaper options that I should consider? And even in this case, it really depends on the resource. So if you compare the two graphs here, these are the x-axis is gigabytes of storage. I forgot to label it. And on the y-axis, you can see the costs. So if your storage is around 100, 200 gigabytes per month, for example, then it might be cheaper to get the data out of AWS, for example, because they offer some initial discounts on the first 100, 200 gigabytes of data that you transfer out. But if you start to increase the amount of data, then getting out from AWS in this example, it might be too expensive up to a certain point. This is because then prices might vary constantly, and after a specific amount, you can get some discounts. So it is really dependent on what you're looking for and your specific use case, but there are several options to consider. Usually, there are other cloud providers that offer storage for a lower costs, and they also include the data transferring up to a certain limit or an unlimited data transferring. It really depends. So based on your specific use case, you should consider and you should compare the different costs. Other recommendations still about cost management: use incremental backups every time that a full backup is not needed. The main reason is the fact that you're reducing the amount of data that you're transferring and storing. So unless you really need the full backup, which still needs to be done on a periodic time frame, but if you can, and it's not fundamental, go for incremental backups. You should monitor and get alerts based on the costs and based on the thresholds that you will set to make sure that all the resources that you're using, all the services that you're using are managed and they're kept below the threshold that you set, or adapt the threshold based on what you can see from the costs that you will incur into. There are auto-scaling features that might also adjust resources. For example, for storaging, most of the cloud providers offer auto-scaling solution. So maybe instead of have a fixed amount of data that you want to store, it is better to have auto-scaling solutions that will increase based on the data that you will send. But this is the case for most of the solutions available right now. You still have to consider multi-region because it's one of the best practices is to have replication and redundancy that is spread over multiple regions, which also means that transferring data from one region to another one, even within the same cloud, incurs some extra costs because they let you pay for the data transfer even within between different regions. So you should also adapt your strategy based on your requirements, but also the costs, the different costs that are present. And as I said, there are tools specifically used to check your costs. Most of the cloud providers have a cost management tool or some specific cost calculators or pricing models that you can evaluate before using these solutions. Sometimes they offer specific reserved instances or some saving plans, which has the risk, though, to bring you into the vendor lock-in issue. But still, sometimes the saving plans that they might offer, especially if you need to store a lot of data, might be an advantage. Keep reviewing your costs, so conduct regular reviews on your costs and your performances, and evaluate if everything aligns with your needs, which might change over time. So make the adjustments. Don't just set up the backup solutions and then keep them there forever. The needs of your company and of your organization might change constantly, so make adjustments in that sense. Cloud native solutions, backup solutions are present. There are multiple ones. So if you have the knowledge about, some of them are quite easy to use, or if you have the possibility to use something for free instead of paying for services to get the same results, that might be an important aspect to consider. Hybrid backup strategies, if you have on-premises solutions or specific cloud, private cloud that you might use to keep the storage, of course, instead of paying an external service, this could be an option, or at least an hybrid configuration. It's always useful. And seek for experts, especially if you're not knowledgeable about the specific topic. Look for expert, get some guides, or ask us, because we're also trying to help in this sense, to check what could be the best way of optimize the costs that you might need for your cloud backups.
Maybe indicate that you're open for questions and comments so that you have a bit of time to breathe.
Yeah, indeed. Yeah. If there are questions, you can interrupt me any moment. That also works for applies for the people online. One good example of a cloud native solution, if you're considering still an integration with the main cloud object storage solution, like the AWS S3, which is the most common one, or Google Cloud and so on, could be Velero. They offer mostly for Kubernetes resources, but also for external resources, backups, which can be scheduled. You can create volume snapshot. You have some extra data protection and some disaster recovery features, and the offsite backups to other cloud providers. So this is a nice integration, especially if you want to apply the offsite cloud storage solutions in terms of backups. This is an example of how it works. So it's an external client that interacts with the Kubernetes API in this case. Then you can set up a backup and get some snapshots from there. But if you want to have more information about the specific tool, we can discuss it later during the section about cloud native solutions. Okay, security measures. This is another very important aspect. There are a lot of considerations. They all apply in terms of security. The same logic applies for backups applies as for storing data. So you should encrypt your backup data using strong encryption algorithms and using the best practices for key management. And this applies for both in transit encryption, so data that you're moving, as well as for data that is at rest, so stored somewhere. And most of the cloud providers, of course, have encryption options that are available, but there are open source solutions. The key management, so for the encryption part, is also important to securely store your keys. Consider some specific modules like the hardware security modules or some cloud-based key management services, and do the regular key rotation. So those are recommendations that apply normally for data in this case. You should have access control and authorization for data and backups. So restrict the access only to the personnel that should be authorized to do that. Apply the least privilege principle as usual. And whenever it's possible, enforce multi-factor authentication. You should have monitoring and auditing systems in place to get any detail on who's accessing your backup data, what type of data they have access to, and when they do it. So constantly review the audit logs, for example, and get alerts if you might incur in some anomalies, and get notifications for the administrators or for any potential security incident that you might have, and use the multiple layers of security. So combine encryption with other security measures, include identity and access control. If you have intrusion detection systems that can be applied to your data for your backups, you should include them, have some security measures for data loss prevention, and so on. So anything security that can be applied to data storage should be and must be applied. The storage itself has to be secure, of course, either in the cloud or on premises. If you can, please isolate the backup storage from the rest of the resources. If possible, you should consider air-gapped storage, so something that is completely isolated and not accessible. Keep some of the store backups offline, or if you really need networking, then use dedicated network segments or VLANs to access that. Testing and validation should be applied on a regular basis. So apply the usual regular security assessment, do penetration testings. Well, in the cloud, it's a bit more complex, but still, you should also do testing on the recovery side. So test that your backup data can be used to recover your actual data, not just store it there forever. Do some mock disaster recovery drills, and have regular tests, as I said, for your backup data. Data classification, we already talked about it. You might apply stronger encryption and security control for the most critical data only, especially if that's an additional cost that you have to consider. So align the security measures based on the importance of data. If you have compliance considerations to consider, please do so, but that's necessary for your organization. And keep the education and the training as part of the security measures that you should definitely consider. So keep providing training to the employees, especially when they have to deal with data security and they have to know what are the best practices available. In terms of automation and orchestration, well, this is an additional step probably, but you should still consider, especially because the cloud offers solutions and the cloud native landscape also has a lot of services that might automate and help you orchestrating your data. With that, you have a better efficiency and you might reduce errors, especially human errors, human mistakes. You can set up schedules that are consistent because they're performed constantly in the same way. You will have less administrative overhead in the sense that if most of the tasks can be automated, then your IT workforce might be used for something else, something more important, or just for additional strategies in terms of security and data protection, for example. Yeah, the backups will be more reliable in terms that, again, in terms of consistency, and the processes can scale and be more agile, especially if performed in the cloud. So if you consider the automation, something that you should set up are scheduled backups, so regular backups at specific intervals. Define some policy-based backups. So use the automation based on data criticality, the different compliance requirements, the business rules that you can set up. Have incremental backups, as I said, is a good way in terms of costs, but even in terms of automation, because you will only get the changes that you need. Automate also the life cycle. So when you have to delete data can be an automatic process as well. Check the backups. Again, an automated verification process is available. And include log and monitoring. Log and monitoring will be included basically in all the different options. Another example of a cloud native solution is Longhorn. Longhorn is a potential alternative to Rook as well, because it provides distributed storage solutions. But it also has built-in backup and restore capabilities. You can see from the dashboard, for example, that they have recurring job that you can apply to have automated backup scheduling and the different types of backups. This is a incubating project. It's one that is gaining some momentum in terms of usage, so it might be interesting to consider. And in terms of orchestration, well, you will try to automate your workflow. And for that, you will have to coordinate tasks, especially if you have different type of backups to create. You will have to consider integration with the cloud services. There might be a need for orchestration if you are in a multi-cloud environment. There are solutions for that as well, or you can create pipeline or automated processes for it. Consider application-aware types of backups. And I'm probably gonna talk about that as well. I will mention it again. What are the application-aware backups? Parallelize tasks, automate disaster recovery workflows, take advantage of the scalability and the flexibilities of the infrastructure, especially in cloud environments. Define policies. As we said, for the automation, it will also be a combination with orchestration to adjust your strategies. There might be self-service solutions that you can use, or portals that end user might use to manage a recovery from specific type of backups. This is also part of the orchestration. And then audit and reporting. So get centralized audit logs, and reporting is also important in terms of visibility, so you can see what's going on. And at this point, we talked about the four first pillars. As I said, the comprehensive backup strategy is something that includes all of them with some extra considerations. For example, we talked about the different types of data and the different level of criticality, but not all the data will require the same level of backup frequency or retention. So you can also differentiate that in your strategy. RTOs and RPOs, so the recovery time and points objectives, might be set differently based on the types of data. The scheduling of the backups might change based on priority and the other metrics. Full and incremental backups, as I said, could be used as a combination of the two. Use versioning to get and restore potential previous version of critical files, or at least to have an historical view of the changes on your solutions. And when you can, offside and use multiple cloud backups. So bring it on different locations, or if you're using the same change region, and include always some redundancy in any case. If possible, a hybrid solution might be the best option. The storage might be secured, as we said. The location that you will define should be defined based on costs, but also security and accessibility. It will definitely depend on how much and how many times you will have to access the data, for example. So the best way is to choose the most cost-effective backup storage and option and retention policy. Keep documentation, or at least document step by step the procedures. This is part of the strategy that you will set up, and should also be part of the disaster recovery plan that you will have for your entire infrastructure. Application-aware backups, if possible, for all the complex applications, should be always included. When I say application-aware backups, I mean types of backups in which the application knows, like the backups takes into consideration the type of application that you're using. Like if you have a virtual machine, an application-aware solution will be able to also save all the reading processes that are ongoing. It will stop the virtual machine and flush the memory, for example, and get also that type of data, the temporary files and so on, and then will restart the machine. So it's something more specific, useful usually when you have complex applications or databases, for example, when you have current reading or writing options. The monitoring and alerting is part of all the pillars, so you will have to include them and set up alerts for any problem that might occur on any unusual pattern that you might see. And keep also get support from vendors and get updates, because things keep changing in the cloud. Vendors might change prices, might change solutions, or introduce something new that might be important for you. So keep the communication channel open with your vendors and check whether they might help you with any type of issue. Okay, we now move to the backup solutions, well, again, backup and data storage solutions that are available. I show you again the cloud native landscape specifically for storage. I already mentioned Rook. We will have a little presentation soon. I showed quickly, or at least I mentioned Longhorn as a potential different solution from Rook. We talked about Velero, for example, but there are a lot of other projects that are available based on your needs. Another good example is CubeFS, which is also an incubating solution. This is a solution that might work within Kubernetes, but also as a standalone solution. So if you're looking for something more generic than just Kubernetes, it's a distributed file system, mainly for object storage, but not only. And I think the main key feature is the fact that it has unlimited scalability. They can reach petabytes or even exabytes without having degradation in terms of performance. And they also include built-in security features. It is easy to use according to the developers, at least, and they provide some easy integration with external tools and solutions as well. So this might be something worth to consider if you're looking for this type of solution. If you're instead looking for something more Kubernetes oriented, K8up or Ketchup, as they named it, it's a specific solution for Kubernetes, but it claims that it's able to provide full Kubernetes clusters backups, which means that if you want to move from one type of cluster, or if you want to move your entire cluster, K8up is a solution that provides that as an option, as a feature, but they also provide automatic backup and restore solutions. It's easy to use. Again, this is according to developers, but and it's highly configurable. Okay, we can move to a Rook presentation if Merlin are ready for that. You guys at IMEC have a lot of expertise using Rook and other open source solutions. So I'll leave you the chair so we can hear from you your experience with that.
Okay, so I'm gonna give a little more technical showcase of what you can do with Rook, specifically around zero trust encryption at rest. Let me look. So Rook specifically, something I want to make a little bit more clear. So Rook specifically, it is marketed as a Kubernetes storage solution, but Kubernetes itself already has storage solutions itself. But the problem is that by default, when you just install a Kubernetes cluster, by default, the storage of that cluster is not persistent. So you can, for example, say that a container running in this cluster, that it stores a database on one of the hosts, virtual machines, or one of the physical hosts of the cluster. But if that host disappears, even though the database will be rescheduled by Kubernetes, it will restart on a different host, the data will be gone. Because by default, the data that Kubernetes uses, it is not persistent. But Kubernetes has support for persistent data, and this is called persistent volumes. So inside of Kubernetes, you can request that certain volumes of your container are actually persistent volumes. And that means that they will remain even if the host goes down, the data will not be lost. But then the question becomes, how do you get from a Kubernetes cluster with just regular storage to a Kubernetes cluster which has persistent storage? And so one of the solutions, and the solution that most cloud providers give you, is to just use their service for persistent storage. But another solution, for example, if you are using an on-premise Kubernetes cluster, or if for some reason you want more customizable storage, then you can use Rook to go from the regular storage that the Kubernetes cluster has, where the data disappears once the Kubernetes machine goes down, to a system where the data remains even if the Kubernetes machine goes down. And so in the backend, Rook, it basically uses Ceph. Ceph is a very mature open source virtualized storage application. It gives you scalable, fault tolerant storage, and it supports both block storage. So these could be virtual disks or object storage compatible with the Amazon S3 API. But it also supports a whole lot of special configuration options, a lot of them tailored towards enterprise and high security use cases, such as encryption at rest. Ceph itself, it is both developed by a very large consortium of open source partners such as Canonical, the company behind Ubuntu, Red Hat, Intel, Cisco, CERN themselves. They are all both users of Ceph and develop the code base itself. And some of the larger cloud providers, such as IBM, for example, actually use Ceph in the backend for their own storage as a service offers. Rook is basically a Kubernetes operator, a piece of Kubernetes automation code that deploys and manages Ceph on top of Kubernetes for you. Ceph itself, it's a very robust piece of software, but it's also quite complex in order to manage it, in order to install it, and in order to install it in a manner so that when one of your nodes disappears, when one of them crashes, that you still have your data. And so Rook basically takes care of that for you. And that's the cloud native part of Rook. It completely integrates into Kubernetes. And even though Ceph itself existed long before cloud native was a thing, Rook basically is this glue code in order to make Ceph into a fully cloud native storage provider. So the result of Rook is that you have a Ceph cluster on top of Kubernetes. And this means that your Kubernetes cluster is running a whole bunch of software that makes up of Ceph. And so each Kubernetes host will then run a container. Inside of this container, there will run a Ceph OSD node. And this OSD node will be the piece of software that actually stores the data. And then the data gets stored on the physical nodes of your Kubernetes cluster or on the virtual machines of your Kubernetes cluster. But Ceph itself, it duplicates your data so that it's available on multiple hosts, so that if one of the hosts disappears, you will still have your data. So I'm going to give some, I'm going to guide you through an example of how to make Ceph storage accessible to Kubernetes and then how to use it inside of your Kubernetes applications. So making a Ceph cluster accessible to Kubernetes applications, in order to do this, you need to create a storage class. A storage class is basically something that tells Kubernetes we have a new storage option available. by default, this Ceph storage will not be available in Kubernetes, but you use this storage class in order to tell Kubernetes how to connect to the storage, where the storage is. And once this storage class is added to Kubernetes, then other containers inside of Kubernetes can actually create storage as part of that storage class. So as everything in Kubernetes, you define a storage class using a YAML. Here you see the YAML of a storage class. And the first thing you have to say is that this resource that I'm creating right now, this is of the type storage class. So I'm creating a storage class. And then one of the things you define in the storage class is where can I find the actual provisioner of this storage class. And so the provisioner would be Rook. So you give it a URL that goes to a sort of URL that explains what kind of provisioner to use when a container requests storage from the storage class. And then you also give it a lot of parameters, such as which Ceph cluster to use. You can also choose the replication and a couple of other options. You can also explain what file system to actually use for the underlying storage, and a lot more properties. Once you have the storage class, once the storage class is created, then you can give any service persistent storage inside of the Ceph cluster by giving it a persistent volume claim. So a persistent volume claim is basically a way to create a persistent volume for a certain service. Again, this is something that you define using a Kubernetes YAML. First, you explain that this is of the type persistent volume claim. And then you give more information about what should this volume look like. So we need to refer back to the storage class that we just defined. We also need to explain how to read and write to that storage. Kubernetes volume claims have different ways to different types of access modes. So for example, you can have storage that can be read by multiple containers, but that can only be written to by a single container. Or you can have a volume that can only be read by a single container and only be written to by a single container. And so depending on what your application actually needs, like does it use the underlying storage, do multiple containers use the same underlying volume, or does each container have their own persistent volume, you can change the access modes. And then also you explain how big this volume can actually be. And this is the total size. So if in a volume claim, for example, you give the storage 10 gigabytes, it will not actually use 10 gigabytes inside of the storage cluster. It's simply the total size, the maximum size of this volume. So in order to add virtualized storage to Kubernetes, well, the first thing you need to create is a Ceph cluster. The Ceph cluster is managed by Rook, and so that's a resource of the kind Ceph cluster. Then the second thing you need to do, so the Ceph cluster resource, it creates the Ceph cluster inside of your Kubernetes cluster. The second thing you need to do is tell your Kubernetes cluster that it can use the Ceph cluster to actually to give storage to containers. And that's something you do by creating a storage class. And then for each container that you want to have persistent storage, you create a persistent volume claim that points back to the storage class, and then the storage class points back to the Ceph cluster. So this is how you go from a Kubernetes cluster that has no persistent storage, where anything that is stored disappears when the node goes down, to a Kubernetes cluster where you have persistent storage. But you can go even further. So we see some customers who, even though they use a cloud provider that already has persistent storage available, they actually build their own, they use Rook to build their own persistent storage solution on top of it. Because they want more advanced functionality, such as very granular encryption at rest. This is also a good way to use Rook, even if you already have persistent storage. You can also use Rook to actually start to encrypt that persistent storage, even in a zero trust capacity, where, for example, each individual container, each individual volume is encrypted with a separate secret that is only accessible to that container, so that even if one of the secrets leaks, the leak is only isolated. The leak is isolated to the data of that single container. There are a couple of ways to do encryption at rest with Rook. The first type is cluster level. This basically encrypts the entire data with a single key. The second level is at a service level. This means that you encrypt each persistent volume with a different key. This is the zero trust kind of a way of encryption that I just talked about. But you can go even further. You can even have encryption at an object level, where each individual object that is stored inside of Ceph has their own encryption and decryption key, has their own access authorization parameters. And so this is one of the safest ways to do this encryption. What we often see in companies is that often companies actually use a combination of both, because these encryption methods are so incredibly performant, their overhead is incredibly small. It's actually possible, and it doesn't really degrade the performance a lot when you use multiple levels of encryption. So the first type, encryption at rest for block storage, this is the easiest type to configure. So when you define your Ceph cluster, when you tell Rook to deploy a Ceph cluster on top of your Kubernetes cluster, then you simply say that you specify the configuration parameter encrypted device equals true. And that's it. That's the only thing you have to do with Rook in order to get encrypted storage. You can go even further and connect it to a key provider such as Vault. But if you just want encrypted storage at rest, then you just turn that configuration parameter to true, and then you have it. Very easy. You can also use HashiCorp Vault as an open source key management system, so that the keys are stored in a separate location. And HashiCorp Vault is the entity that decides who can access the keys. And then Ceph is the entity that gets the key and then decrypts the storage. Then decrypts the storage when customers request it. In this method of interaction, the keys will still, at runtime, will still be present on the Ceph servers. However, with HashiCorp Vault, you can go even further and ensure that the decryption keys are never present on the same server as where the data is stored, simply by having a methodology where every time a client requests some bits of data, this request actually gets piped through HashiCorp Vault. And so Vault is the entity decrypting the data and then sending it to the client. And in the other way around, when the client does a disk write, then HashiCorp Vault is the entity encrypting the data and then sending the encrypted data to the storage cluster. This further reduces the risk of a compromise and further isolates the impact of a compromise by completely separating the data from the keys. In such an environment, if the encryption server is compromised, then Vault then the attacker actually, or if the storage server, if the storage server is compromised, then the attacker can't read the data because the attacker doesn't have the decryption keys. If HashiCorp Vault is compromised, then the attacker only has access to the data that is in flight. So if you discover the compromise quickly, then only the data that was in flight will actually be compromised because HashiCorp Vault does not have access to the entire archive of encrypted data. A second way to do encryption is encryption at rest for block storage at a persistent volume level. So this means that you basically create a separate storage class. So the storage class we initially created to tell Kubernetes where to what cluster to use for storage. You can also add additional parameters to that to actually use encrypted volumes and then point it to Vault in order to store the decryption keys. This will make sure that each Kubernetes service, each Kubernetes container, they each have their own decryption key and they each contact Vault in order to get that decryption key so that you get a truly zero trust environment. If one of the services is compromised, only the data of that service will be available to the attacker. Then finally, Vault also, Ceph and Vault and Rook, the combined platform of those three, they also support encryption at rest for object storage. In this system, the data the data is decrypted at the object gateway. So if you have object storage on Ceph, then basically that means that you add an additional service in your Kubernetes cluster that basically translates the S3 object storage API to the regular Ceph block storage API. And so if you use encryption at rest for object storage, then you have a complex sequence of handshakes every single time when you request an object, where in order to decrypt an object, the object gateway first needs to get a secret from the client, then it needs to get a second secret from Vault, and then it can use those two secrets to actually decrypt the data. And so this, again, is a very good way to isolate the impact of a security breach. If the Ceph object gateway is breached, the Ceph object gateway itself, it cannot decrypt all the data. It can only decrypt the data at rest because it needs a key from the client. In order to actually decrypt the data, it can't just request all the keys from Vault itself. In summary, Kubernetes offers an API to operations code. And one of these pieces of operations code is Rook. Rook is a piece of operations code that basically deploys and manages persistent storage on top of your Kubernetes cluster. Rook is very useful to use. It's very useful when you have either when you don't have persistent storage and want to get persistent storage on your cluster, or when you want to tweak specific storage configuration parameters, such as how you do encryption, if you want zero trust encryption and things like that. The encryption at rest of Rook, you basically have three types of encryption at rest. You have a per cluster encryption at rest, which encrypts the entire cluster with a single key. You have per microservice encryption at rest, which encrypts the entire data of a single microservice, each with a separate key. Or you can have per object encryption at rest, at which each individual object has a separate key and is encrypted separately.
Thank
So,
you.
and I'll give the word back to Luca.
And of course, if there are specific questions about your use case, or if anyone is interested to know more, I guess they're free to contact you for more details, or they can ask questions either online or in real life. Yes, so let's conclude with some considerations. First of all, the fact that we didn't cover all the potential aspects, especially looking towards the future. There are some additional topics that might be relevant. For example, now we see an increase of using artificial intelligence for basically everything. So strategizing and automating backup solutions might be something that we can give to AI or to machine learning, because they have additional power on recognizing specific patterns, identifying some potential risks, so they can be used as a preventive measure, but also for automation and scheduling of your storage allocation if you need to optimize it, if you're looking for anomalies or changing cloud based on pricing, for example. That's something that artificial intelligence might be considered in the future, but even right now. We didn't talk about serverless backups. This is a trend that is growing. There are solutions already available. There will be definitely more in the future. This is something that we can discuss. Data protection as a service is a specific service model that covers the data protection, and this will, of course, potentially include backup, restore, disaster recovery, encryption, and so on. Hybrid and multi-cloud backups, well, we talk about that, but it's something that the hybrid solutions and the multi-cloud environments are usually the most used or the most chosen option in terms of cloud architectures. So we will shoot and we can focus mostly on hybrid backup solutions and multi-cloud backup solutions. Immutable backups is another interesting topic, especially in terms of security, that makes the backups only read-only after the creation. So you will prevent any type of tampering of the data that you're storing. And maybe a specific focus on the data lifecycle management in terms of cost optimizations can be a solution. To conclude, again, I highly recommend to check on our website. There you find the recordings of all the webinars. This one as well will be included. We have a sandbox environment in which you can spin on your Kubernetes cluster for free. This is something offered by our partners, IMEC. It's handled by them. It's a very easy way to start playing with Kubernetes. You just follow a couple of steps and you have your Kubernetes environment ready to use to test some applications, to learn how to use it, and so on. So something for the future, we will produce some white papers, one specifically for trying to condense what we've been talking for the last 1.5 hours in a way that it's more readable and can provide some indications, some practical indications that might be useful to read and consider. We will keep working on data storage and backups, go a bit more in depth on specific subject or sub-subject. A potential focus on the cost analysis, it's something that we're evaluating for the future because we know that it's an important request, because in the end, we're talking about money. So we can provide some guidance on general on cost analysis and evaluations in terms of cloud, but also in the specific use case of backups, as we just mentioned during the webinar. for that as well, practical approaches. If you're interested in any specific tool that I mentioned today, or there are others that you might be interested into, we can offer guidance, we can organize workshops, we can provide recommendations, we can set up a webinar and so on. So anything you might be interested, lsec.eu, general website with all our projects, opencloudification.com for the specific OpenCloudification project. If there are questions or comments now or later on, or never, online as well. Thank you.
Thank you very much, Luca and Marlene. Very extensive and very interesting indeed. So I think in the next case, we can maybe work on some more practical examples of these things on the one hand side, and I think there's a lot of material in there that suits for a white paper.
Yeah.
As we already discussed, so that's definitely a next follow-up activity. But great work. Any questions from people online that you can see?
No questions for the moment. So I guess we can stop the webinar, and then we will continue with the rest of the agenda for today. So thank you for everyone being online, and see you in the next webinar next year.
Which will be in January, I think, second week.
We will then provide the schedule probably for 2024 as well. Okay, thank you everyone. Bye.
Bye.